Well, hello and welcome YouTube. Mr. Robbins back here with another brand new exciting video. Let's get straight into the action. We are going to be looking at triangle congruence conjectures. These specific ones that are abbreviated right here. SSS, SAS, ASA, AAS, and HL. What the heck do those things mean? We'll figure it out on the very next slide, at least the first four. Some other ones that don't work, of course, just to make sure that you don't use them. CPCTC, we've kind of heard of this. We'll go over it again and we'll look at some overlapping figures as a part of an example of all the other stuff. This is the highlight, guys, specifically these four. These are the highlight of what we're looking at. And I'll tell you what, with everything combined here today, 18 example problems. 18 of them. I do not want to spend a long time on them. I want to spend less than a minute per problem on average for sure. But I want to first dive into what all this stuff means here. I'm glad you're here with me. Let's go. All right, guys, let me just read this out loud, and then I'll break down what I meant here. Recently, we've been investigating all corresponding parts of figures, including triangles, not just any figures, but also triangles, for congruency to determine whether said figures were congruent to one another. So we looked at all parts, angles, and sides. If all of them are congruent, then the figures are congruent. However, triangles are special in that they only need a limited amount of known corresponding parts, a certain sequence of sides or angles to determine congruency. They don't need everything. One of my students actually brought this up one day. They were like, Mr. Robinson, if I just know all the sides are, could I change it? I said, that's a good question. We'll answer this today. In other words, knowing those certain parts to be congruent will be sufficient to then know the whole triangle is congruent. This is also known as CPCTC. Corresponding parts of congruent triangles are congruent. Once you know that the triangle is congruent after getting limited information, then you know the whole thing's congruent. So if I go back really quickly, guys, before we kind of dive into what all these abbreviation things here mean, whenever I talk about like, if you need to prove a murder case in something, I'm like, oh, you need this, you need this, you need that, you need that. You don't actually need everything. You need just enough. If the weapon and the blood and the DNA and the witness is enough, then they'll slam dunk conviction. And then that means everything else then must be true. You might not need everything. All right, just enough. So here's what you need for triangles. And I'm not going to spend a long time talking about like why this is all you need. But here's what you need. Two triangles are congruent to one another should they meet any of the following criteria. You can have what's called side, 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 abbreviated SSS. What this means is if all three sides of two different triangles are congruent to one another, like each pair has a corresponding part for all three sides, like this is congruent to this is congruent to this, and this is congruent to this, then your triangles are congruent. I don't need to know that the angles are congruent for that to be true. I just need to know that all three pairs of sides are congruent to one another and correspond. Kind of cool. I don't actually need everything. I don't need all six parts, just the three sides. Or I could have two of the sides known as congruent and the angle in between. This is known as side angle side. You'll see on the next slide that I use, I call it the included angle. So notice how this side's congruent to this side here. This side's congruent to this side here, and then this angle is congruent to this angle here. Now, it's not just any angle. It's specifically the angle in between the two congruent sides. So when you see side, angle, side, side, angle, side, when you work in sequence there, that's why I mentioned the word sequence. Where is it? Sequence of sides or angles. When I say sequence, it's very important that it's like side, angle, side, that you go to the next immediate angle and the next immediate side, etc., and then it brings it about. Side, angle, side is also another one. Basically what this means, guys, is this angle cannot therefore now be anything else as a result of what you have here. This side cannot be anything else lengthwise, and this angle can't be anything else lengthwise. It's locked in place. There's nothing else that can be true, that can be changed about it. These two triangles have to be congruent once you know those bits of information. Hey, what about angle, side, angle? Okay, well, if two angles were congruent, angle congruent to angle, angle congruent to angle, and the included side, the side in between those two angles are congruent, right? That's how that works. Angle, side, angle, side, angle. And that works. You can also have what's called angle, angle, side, AAS, where you do have two angles congruent and one of the sides outside of it. So, although there is, and you'll see it on the next slide, although here the angle in between has to be congruent, here you can have one or the other here. And there really is a reason why you can either have the side inside the angles or outside the angles to be congruent. And it has to do with the fact that the angles of a triangle always add to a constant 180. If two of the angles in a triangle are congruent, guys, the third angle set is also always congruent. So if you have angle side, you do also have angle side angle, just so you know. So I mean, you would call it angle side, but that's really the reason why either works here. Now I'll show you why you can't have the angle outside the sides work in the next set here. So these are the four main ones here: side angle side, angle, and angle side. Those are the abbreviations for them, and that's what we're looking for. If we have those parts congruent, we're good. Triangles are congruent. All right, now the next slide here shows another set that you can use here in right triangles. I'll get to those in a bit. Let me first go to the ones in red with the description that I have right here. There is a, this is not right triangle, this is just triangle. There is a triangle similarity conjecture known as angle. Technically, it's known as angle only, because the third angle is automatically congruent. I just want to say this because all the other ones you saw were 3 letters each. So I just want to say that. Anyway, there's a triangle similarity conjecture known as angle. Similarity, not congruence. That's not the case for triangle congruence, though, guys. If I have all 3 sets of angles in 2 triangles congruent, does that make the triangles congruent? Not necessarily. Look at these. This angle here is congruent to this angle in this triangle. See how they're the same? This angle is congruent to this angle in this triangle. And this angle is congruent to this angle in this triangle. Does that make the triangles congruent? Nope. One's truly bigger than the other, right? You always need at least one pair of corresponding sides to be congruent. You notice in all these, you at least need one of these needs to have an S in it. S, right? These all need an S in it in some sort. You can't just have angles only. Side, you don't need any angles, but you do need angles. You do need sides. Also, angle side, and you'll notice it says ass. It's not a triangle congruence conjecture. That's really a way to remember it. Books are going to say side angle because they don't want to say a bad word. But here's my point to it. Don't say the bad word. It's a bad word. No, you can't have a bad word. So that's part of the point. If you notice, oh no, you said a bad word, right? That's an example of, you can't use that. It's not a triangle congruence conjecture. Now, there's another part that says with the exception of right triangles. We'll get into that. Let me show you an example of angle side, guys. And you'll notice that this actually is angle side, like for show. That notice how these 2 angles are congruent in these 2 triangles. These 2 sides are congruent, and these 2 sides are congruent. Basically, I have 2 sets of congruent sides, and then the angle outside of the congruent sides is also congruent. But notice how the triangles aren't congruent. And you might say, Mr. Robinson, you clearly drew this triangle to be smaller. Well, I changed the side so that it bent inward. But is this angle not? Watch this. I'm going to go right over this. Are those angles not congruent to each other? Were those sides not congruent to each other? Do those not look congruent to each other? Guys, these are congruent angles, congruent sides. These triangles are not congruent, though. I can manipulate this triangle in a different way in angle side format, and I don't necessarily have congruent triangles. So this is not a valid congruence conjecture. There is still open opportunity for you to make different triangles. Whereas in these other ones, there is no open opportunity for me to make a different triangle when I know all 3 sides are congruent, or 2 angles in the side in between. These cannot be manipulated in a different way. This one can. Angle side can. There's one exception to angle side that works, and it's in right triangles. That, we don't call it angle side in that case. We call it HL, which stands for hypotenuse leg. So here's an example of hypotenuse leg, which says if I have a right triangle and I know that the hypotenuses in the triangle are congruent and one of the pairs of legs in the triangle are congruent, well, then the triangles are congruent. And the reason is because I can use Pythagorean theorem if I ever wanted to. If I ever knew 2 of the numbers here, I could always use Pythagorean theorem to find out the third side. And then I could find out those were congruent with Pythagorean theorem, because right triangles do that. And then guess what I have? Either side angle side, or side. So because of right triangles' nature of being locked in a certain way, Pythagorean theorem allows us to have all that. Now, you don't have to do all that. The point is, once you know that a set of hypotenuses are congruent and a set of legs are congruent, that you actually do have congruent triangles. We call that HL. I'm not going to dive deep into HL, guys. My highlighted stuff is really going to be these four right here. All right, let's go straight to the examples and let's see what we got. Now, you're going to have to know some other features with these things, such as properties. I've mentioned the reflexive property, vertical angles, corresponding angles, alternate interior angles. Those things will pop up here for us to be able to mark some certain things to see if these things are actually indeed congruent. Now, these will be up top as well, but as you notice, sometimes I have to like scroll up and down to see a figure in full. I apologize, but here's your side, 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 angle, and angle, angle, side. Two triangles would be congruent here. Okay, 18 examples. Let's go. Which postulate or theorem, if any, could you use to prove the two triangles congruent? So can we use any of these four here? Well, in this first example, I have two triangles that happen to share a side together. Now, they tell us that this is congruent to this and this is congruent to this. So far, we have side, side. That's not enough. We do need a third set of sides to be congruent. But because we have a shared side in these two triangles, I can say that this side is congruent to itself. So by the reflexive property, remember that's called the reflexive property, a shared side, I do have side, side, side. Remember guys, this is two different triangles. That's a triangle here, like this, and that's a triangle here, like this. I'm splitting them apart to show you. So yeah, we do have side, side, side with here, yes. So I'll say yes with side, side, side. I'm gonna put the little congruence thing just for be creature of habit. Make sure that I'm kind of using that each time. This is called the side, side, side congruence conjecture, or congruency conjecture. All right, this one here, guys, we do have right angles. Whether or not they're right angles doesn't automatically mean HL, by the way. You still need the hypotenuse congruent, which they are, and then you need a set of legs congruent, which I don't seem to have. And, by the way, it's not always hypotenuse leg. It could be side angle side from the get-go. What I do know, though, is they are right angles. I do have hypotenuse congruent. I don't have legs congruent, right? I don't know if one of these triangles might look like this, and then the other triangle, well, the hypotenuse still needs to be congruent, but I don't know if they might look like this and actually not be congruent. Yeah, hey guys, there's not enough information. It's not possible to know that they can be proven congruent here. There's just not enough information. Even if I wanted to play some sort of angle, side, something like that, I only have one pair of angles congruent and one pair of sides congruent. Now this one, once again, we have two different pairs of sides congruent. That's a good start for side, side something. It doesn't look like I can use reflexive property. I can't figure out to find out these two sides congruent. I can't just pull that out of thin air. But because these triangles are drawn the way that they are here, guys, I have two lines that intersect here. And they form two different opposite angles to be congruent, this one and this one here. Those are known as vertical angles. Vertical angles are congruent with each other. So, hey, I do have enough information actually right here. Let's take a look at this. When I draw that in, and here's the point. You're going to have to come up with some of this information on your own. Some parts will be given. Other parts will be determined based on the nature of what you have. I have side, angle, side with side, angle, side. Yes, these two triangles are congruent by side, angle, side. Okay. So that's kind of what we're doing here. Now, I'm going to dive in some with letters in a bit. Let's do 4, 5, and 6 and take a look at these. More of the same here. Here I have two triangles, one right here and one right here. Now I have a shared side once again in both of these guys, so I can mark this congruent to itself, and that's with the reflexive property. But I think that's the extent of what I can do. I have side, side. I don't see a portion where I can do side, 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 or side, angle, side, or anything like that. I don't have enough information here. This is once again one of those not possible things. I have 2 bits of sides, but not 3. It's not possible. Well, these ones are marked kind of straight up here. I got angle, and then immediately skipping a side, I got angle and then side. So angle, angle, side with angle, angle, side. Make sure it's a 1 arc mark, 2 arc mark right there, and it seems to line up the way that we want them to. So that is yes by angle, angle, side. There are tricky ones that they can do to, to really trick you. Meaning, what if they gave this one a 2 arc mark and this was a 1 arc mark right there? Now parts wouldn't be corresponding necessarily because that side would be next to the 1 arc mark instead of the 2. So they could do some tricky things, and suddenly it's not angle, angle, side anymore. It's kind of weird, but this one is. Hey, I have vertical angles again here, only this time I got to draw 2 arc marks because we already have a 1 arc mark on these bits. Do we have angle, side, angle, angle, side, angle? You betcha, guys. These are congruent by angle, side, angle. Hopefully some of this is making sense here, and all you're stating is that these triangles actually happen to be identical just from the bare bones bit of information that we have. If you have any of these four, you are golden. You are golden. Now we're pulling in some new information on top of that to make these things work the way that we want them to. All right, now with these guys, I'm going to continue on, only I'm going to make triangle congruent statements as well. I got to find the parts that correspond when they are congruent, if they are congruent. So I have two triangles here. I have a triangle that has A and W and C in it, and another that has W and C and R in it. I have two sets of angles congruent, not enough yet, but by the reflexive property, the shared side WC, right, this WC is kind of, I don't know, congruent to itself. And then as you can see, guys, here, I do have this angle, side working with angle, side right here. I do have both triangles to be congruent, but I got to make a congruent statement. And you got to go, in order. So let's say I call this triangle ACW. ACW. It goes from the 1 arc mark congruent angle to the 2 arc mark congruent angle across the congruent side. So here on this side, I need the 1 arc mark congruent angle to the 2 arc mark congruent angle and across the congruent side. So that's a congruent statement I can make. I decided to say ACW. You could have said WAC, whatever, but then this needs to correspond with it. Anyway, this was, guys, by angle, side. These two are congruent here. Now, I had to first come up with this side to be congruent to the side in the other triangle, whatever, CW congruent to WC using the reflexive property to then make that conclusion. Okay, let's check out this one, number 8. This one's already kind of pre-drawn out. It looks like we got a side angle side working with a side angle side. Yeah, we can use that. Let's call this triangle JLK. I think it'll work out saying go across the 1 tick mark to the 1 arc mark to the 2 tick mark. So triangle JLK is congruent to, so let's go across the 1 arc mark. Hang on 1 second. Sorry about that. I have family over. So the go across the 1 tick mark to the 1 arc mark to the 2 tick mark right there. And then that would be triangle UTV right there. So that is by side, angle, side. Okay. Again, hopefully this is making sense. I got to kind of put a rush through it at this point when we have 18. I have 10 more examples to cover with all this. All right, lastly, number 9 here. Once again, it looks like we got an angle side angle going. I'm not trying to trick you on some of these ones here, but we got an angle side angle going right there. How can we name this thing? Let's GBR. Let's do that. Triangle GBR, 2 arc mark, 1 tick mark, 1 arc mark going across there, GBR. And this is oriented the same, so this was pretty easy. CSD right there. Congruent to triangle CSD by angle, side, angle. It's pretty easy when they're kind of laid out in order. They kind of went from hardest to easiest, didn't it? All right, moving on. Let's move forward. All right, let's take a look at some that are HL, potentially, because if they cannot be proven, right, not possible. So HL, once again, is in right triangles. If you have a pair of hypotenuses congruent and a pair of legs congruent, then the triangles themselves are congruent. This is a form of angle side that we can actually use, but we call it HL. So here we have a right triangle here and a right triangle here, and then they share a side using the reflexive property. So again, this right triangle, yeah, it looks like we have hypotenuses congruent in PQ and in RS right there. And then these two sides are shared right here, SQ, and both triangles that are congruent, and those are each legs that are congruent. So yeah, we have an HL thing that we can use here. If I call one of the triangles, how about PSQ, triangle PSQ, what's that going to be congruent to? Triangle, we need to go, apparently it's the short leg. Well, it's the unmarked leg, we'll say that. The unmarked leg will start on R. We'll go in the unmarked leg to the right angle, Q, and then we'll go across that congruent part, S. Again, parts that correspond are absolutely important. Whatever I name the first triangle is up to me. I generally like to do alphabetical order. In this case, I didn't care. But anyway, that is by HL right there. But anyway, once you name the first one, the second one just needs to follow up with corresponding parts. I'm sorry, I don't know what makes that thing glitch. That happens every so often, and now my family member is probably trying to request something from me here. All right. Then the next part here, number 11. So there's a right angle symbol here. Sorry. Does that mean that this is a right angle? It sort of does, because this is a linear pair, right? This adds to 180, and if this is 90, then this is 90, right? A linear pair of right angles there. Yeah, they work. So they're both right triangles. That's good. The reflexive, there's a lot of reflexive property here today, guys. Reflexive property states that this segment's congruent to itself. So I got congruent hypotenuses and a congruent set of legs in two right triangles. Hey, I do have two congruent right triangles here. Let's call it triangle, what's alphabetical? JKLN. JKLN, triangle KLN is congruent to triangle, this is kind of reflected, right? So MLN, as far as corresponding parts, MLN, this is by HL. All right. Hopefully you are feeling this one out. Let's keep moving forward. So we did all of these ones right here. We're going to see these a couple more times. I don't know if we cover HL again. We're going to see these a couple more times when we look at CPCTC. And here's what CPCTC does, guys. Once you figure out, this is like the murder thing again. Once you figure out the triangles are congruent, that means all corresponding parts then thereafter are congruent. Not just the parts that we found. We said the triangles are congruent. That means all the other ones are as well. So it says explain how you can use any of these here with CPCTC to prove this statement true. So I have a statement here, guys. I want to figure out that the segment TV right here is congruent to the segment YW. Well, I'd have to do two things here. I can't just state that they're congruent. What I'll have to do is find a way to prove the triangles are congruent themselves, outside of using TV and YW as segment lengths. If I can prove that the triangles are congruent, then that must mean that those segments will be congruent thereafter. So can I do one of these on here? These arrows, just so you know, guys, these arrows mean lines are parallel. Not congruent, but parallel. And this might be important for us. We do have angle with side, awesome. But I need side, I need angle, side, angle. I need something like that for this. Can I use that? Maybe these parallel lines will help us. Let me extend this just to give you a little bit of perception, guys, because this is a tough thing for people to notice. Can you tell? You're going to have to look very hard at only what's in blue for a moment. Can you tell that with that line extended, sorry, and this line extended, that you indeed have two parallel lines cut by a transversal? And if so, can you happen to notice that, hey, this angle would be congruent to this angle because they are corresponding angles? Look at the blue only. Erase everything else in memory but the blue. Do you see that? Do you guys see the corresponding angles that are congruent there? Because I do. So those are corresponding angles. Now, why did I mark those ones specifically? Because they exist in both of these triangles. So let me delete everything but those corresponding angle marks right there. All right, let's check that out. Those angles are indeed congruent because they are corresponding angles because these lines were parallel. So that was information that we used. Are the triangles congruent now? Angle, angle, side, baby. Angle, angle, side. Angle, angle, side. Yes, sir. Triangle TYV. TYV. They're even oriented the same. Is congruent to triangle YXW by angle, angle, side. Awesome. Now, we need to see if that proves that segment TV is congruent to segment YW. Are these now congruent to each other? Well, the only real question we need now is, do these parts correspond? Because you know what? When the triangles are congruent, corresponding parts are now congruent. That is CPCTC. Does TV correspond with YW? T and V are the first and third letters of this triangle, and Y and W are the first and third letters of this triangle. You betcha, guys. These are the corresponding parts here. And so, yes, TV, segment TV is congruent to segment YW by what's called CPCTC. The fact that the triangles are congruent means that the corresponding parts are congruent. Therefore, those segments are congruent. So it's just another added step. That's it. It's just one more final step in saying that you found out the triangles were congruent, and hey, CPCTC says that those are congruent. All right, how about segment BE congruent to segment DE? Once again, not enough information right now to say that they are, unless I can find out these two triangles are congruent. I got angle, angle. That's enough for triangle similarity, but not triangle congruence. Can I get a set of sides that are congruent? CE. Reflexive property, right? Segment CE is congruent to itself by the reflexive property. Remember, two different triangles. I do have angle, side, angle with angle, side, angle. That means that triangle, let's call this a BCE, alphabetical, triangle BCE is congruent to triangle to the unknown unmarked one to the one arc mark to the two arc mark. So unknown to one arc mark to two arc mark. DCE. This is by angle, side angle. Therefore, let's see, is BE congruent to DE then? Do these parts correspond? BE, DE. First and third letters each? Yep. Segment BE is indeed congruent to segment DE by CPCTC. Corresponding parts of congruent triangles are congruent. Awesome. Awesome. Last one of the CPCTC bunch, I believe. Yes, it is. Segment KN congruent to segment NL. Once again, can we first state that triangles are congruent? Well, this one's going to be a little more complex here. We do have one set of sides congruent, and that's it. We have that they're parallel as well, but we don't have any other sets of angles or sides yet. Well, in these two triangles, reflexive property said that these two sides are congruent. Awesome. We have side now, right, with the shared side bit. With these two parallel lines, though, it gets a little tricky again, but check this out. With these two parallel lines, do we have a transversal that forms angles in both triangles? Yeah, look at the segment KM right here. Two parallel lines, boom, boom, cut by a transversal. Look inside the triangles. Look at this angle here and this angle here. What are those? Look at the blue only. Those are alternate interior angles. With parallel lines cut by a transversal, alternate interior angles are congruent. And when they're congruent, we do have, when you have parallel lines, alternate interior angles are congruent. And now we have that side, angle, side with side, angle, side in both triangles. So, triangle LKM, LKM going across the one tick mark to the congruent angle to the other tick mark. From here, across the one tick mark, congruent angle, other tick mark. So that's NMK, congruent to triangle NMK by side, angle, side. All right? Let's see if KN is congruent to ML. KN, is KN congruent to ML? KN with ML. Yes, those parts corresponded. And so they're good. KN is congruent to... I don't think they're trying to trick you. Like, we know that they are. I think part of it is making sure you wrote your triangle congruent statement correctly. And I did, by CPCTC. You need CPCTC. When you start learning things about, like, a quadrilateral, like parallelograms by nature having angles bisect each other, when you start learning that, you do need things with CPCTC. It's a bit of a requirement. Hopefully it doesn't feel like, why do we have this added step? It's actually really important. And triangle congruence is really important for everything else geometry, I promise you. All right, that's CPCTC. Let me do some more complex looking problems with overlapping figures. A lot of reflexive properties going to come into play here. This is the last bit. I'll kind of rush through it. All right, you can prove overlapping triangles congruent. You can also use the common or shared sides and angles of triangles in congruence proofs. Name a pair of overlapping congruent triangles in each diagram. State whether the triangles are congruent by side, 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 angle, side, angle, side, angle, 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 side, or HL. So just to kind of not spend too long on this one, guys, I do have in overlapping triangle form, I have a triangle right here in ACE. If you notice that one, I'm going to redraw these to kind of help you out. That's ACE in such a way that we have a one tick mark here on AC, we have a two tick mark here on AE, and then some congruent angle with some other triangle here in a bit, right there on angle A. And then over here, I have triangle ADB. ADB. I don't know if I'm corresponding parts when I say ACE with ADB. But in ADB right there, I have a two tick mark on AB, a one tick mark on AD, and then this mark right here for all of A. We indeed have side, angle, side right here for these two triangles. Looks like it's a reflection though, right? So triangle, let's call this EAC. EAC going across the single side and the double side, tick marks, and then single side, double side, DAB, DAB, triangle DAB by side, angle, side. All right? Looking good. Let's take a look at number 16. Triangles here and here, right? Sorry for the kind of rough drawing. But those two, oh, sorry, I guess I got to separate them, huh? All right, but anyway, you got two triangles there, right? I got a triangle in FIH. It's a right triangle as well. That doesn't necessarily mean HL. In fact, I don't think this one is HL. See, drawing them separately is, you need the triangles being together sometimes to really help you find some of the information. And in this case, I will actually need that. But to have them separate, that'll help you determine which parts are going to correspond. So in this first triangle here, this was going to be FIH. I'm sorry for me being in the way. My face is actually covering a watermark in the background, so me moving my face won't change much of what you get to see. And this is triangle GHI. Now in FIH, I is the right angle, and GHI, H is the right angle, and then we have congruent tick marks here and here. This alone, when they're separated like this, show that there's not enough information right here for side angle side, for HL, for anything like that. There's nothing that shows these hypotenuses should be congruent in the main drawing either, but we do have a shared side in IH right here, which would be congruent to itself. But again, in a separate state, it's a way of stating that this is congruent to this. Now we have side angle side with side angle side right there. Right? So now we have enough information where we can say triangle FIH is congruent to, when I said FIH, I went across the unmark to the single tick mark, right angle, double tick mark. Unmarked, single tick mark, right angle, double tick mark. GHI, triangle GHI. Again, it looks like another reflection. Is this HL though? No, we don't know the hypotenuses. We know side, angle, side. Remember, HL is an exception to the angle side rule. This is side angle side right here. There we go, another side angle side there. Got two more, and that's it. All right, name a pair of overlapping blah, blah, blah. Once again, look, all these are reflections. I don't know if you can tell. All these are reflections here. So, but it does help to do the redraw right here. Take a look at this triangle right there. Let's see what we have here. That's P, T, S. Now, within here, on S, we know that angle here, and we know this little tick mark. This tick mark is just for this part, just so you guys know. Now, that means this tick mark is for this part here, just the segment, so I can't put a tick mark here as well, because it's not for all of T to P, it's just for T to A. So, this is all we have so far in this triangle. Now, in the other triangle, and again, sorry for kind of the squirrely drawing here. In the other triangle, I have R, T, and A. And it looks like A is congruent to S, apparently, and then we have this tick mark here. Again, not enough information with just angle and side. Here's where we get another reflexive property. Not a shared side. We have parts of a shared side, like TS is a part of that thing, but not the full thing. Here's where we have a shared angle. You notice the angle T exists in both triangles? Do you guys notice that? Angle T exists in both triangles there. Check this out. Let me see if I can group these together here. Look at this overlap right there. You see where T is? See that overlap on T? This isn't perfectly drawn, but there's that overlap. It's congruent in both triangles here. This T is congruent to this T here, despite what it makes outside of it. That is also a version of the reflexive property. That is also a version of the reflexive property. Now here, this is angle side angle with angle side angle. I could say triangle TSP, teaspoon, is congruent to triangle. I went from double arc mark across single to single arc mark, double across single. So T, whoops, I'm writing an A. T-A-R. That is by angle side angle. You know, when I planned on doing this video, I thought this would go a lot quicker. I apologize. Some of these problems I just got to talk about. All right, last problem. Can we see them right here? We have big old triangle right there. It's almost like the right angle one. There's a little bit of a difference here. And if I actually made a 2-column proof out of this, we'd have to play a little bit more with this. But with you guys, I'll just mention what I got. I hope that's okay. All right, so these two triangles right here, let's kind of relabel them and figure out what we got. So I know there was a C on top right here. So that's C-F-E. And notice on E right here, just this part within this triangle here, there's 3 arc marks. That's this guy. Now, F is a combination of the 2 arc mark and 3 arc mark. We'll get into that in a second. Now over here we have D and E and F, and this part of F is this guy right here. That's the triple arc mark. Okay, so here's all we have that's a for sure so far. Angle with angle, and that's it. Angle's not enough. Now FE is a shared side in both of these, so by the reflexive property, these two are going to be congruent to each other, right? That's congruent in both of them. And then the last one, guys, we actually can say that this whole angle is congruent to this whole angle because this is a combination. This is using kind of the angle addition postulate. If I have two parts of congruent angles merged together to form a larger angle, they'll be congruent with each other. That's not really a technical proof statement. I hope that's okay that I state that. It's not a technical proof statement, but there is logic to that can be provided. You'd have to build the proof for that, not just in one step, but in like 3 steps to make that statement. But yes, angle F is congruent to angle E right there. As far as this bigger angle F that we have on these two triangles. Obviously, you'd be talking about the figure before, and you'd say angle CFE is congruent to angle like DEF, like that. That's how we do that. All right, so as far as congruent triangles go, and our last problem here, which ones are congruent to what? This is, first of all, this is going to be angle side angle, and this is going to be triangle, let's call this FEC. FEC is congruent to triangle, let's go EFD. Not let's go EFD, that's if F was a single arc mark, E is a single arc mark, etc., and then across there. And that is it by angle side angle. All right. And that is the last one, guys. So this is a little nutshell without actually making 2-column proofs. This is us looking at these congruence conjectures here, a little bit of HL, had some CPCTC along the way, overlapping figures just to get a little different with it, show you some other reflexive property things. And that's all I got. So that ought to do it for me, guys. Let me know if you have any questions. Ask them down in the comment section below. Thank you. Take care.